to write down, and what you're writing down might at first not make a lot of sense. So I'm just going to give you some time to write it down, and then we'll talk about what does it mean, and it actually means something that you've learned probably long ago in 5th grade. So here is our first slide. It's called the division algorithm. I'll give you some time to jot that down. Division algorithm. Okay, so we'll take a quick trip down memory lane to when we first learned about division. Do you remember some words like dividend is the thing you divide? And you divide by the thing that is the divisor. So you take the dividend, divide it by the divisor, and the answer to your division is the quotient, but sometimes you have a remainder. They're basically just saying instead of numbers, these are now polynomials. Okay, so that's why they're using function notation down here. F of x is the dividend. It's this big polynomial that you're dividing. That's the thing you put under the division bar like we did in the warm-up. D of x is the divisor, the thing that you're dividing by. And if you multiply that thing by whatever you get for the polynomial at the top, the quotient, okay, they're going to multiply together, give you some new terms. If you add the remainder to that, then you will get your original function f of x. So it's just repeating the thing that you always knew true about numbers. Right? Take 17 divided by 5. It'll go in 3 times with a remainder of 2. So 5 times 3, divisor times quotient is 15, plus the remainder 2 is 17, the thing you had before. And that doesn't change just because they have x squared, x cubed, and x to the 4th. Now there is some extra statements in the division algorithm that they just have to kind of clear up. So one of them is d of x cannot equal 0 because you are not allowed to divide by 0. You didn't in 5th grade or 6th grade, and you won't ever, right? Divide by 0. Also, they'll say something like the degree of the divisor has to be less than or equal to the degree of the dividend. So, like the thing that's underneath the division bar, it has to have a higher or equal degree to the thing that you're dividing by. Otherwise, we can't do like how many times do I multiply x to get x cubed. I can't do it in the reverse order. What would I have to multiply x cubed by to get x? I can't make it small and still have to be a polynomial. Okay, so they're just saying those things. Otherwise, it's just basic division. Okay, the next thing we want to talk about is the remainder theorem. So division algorithm talks about that quotient, that divisor, that remainder, and now we're going to look at what kinds of things can those things tell us. Well, the remainder theorem says if a polynomial f of x is divided by x minus k, then the remainder is f of k. I'm thinking, what does that little then statement mean? Then the remainder is f of k. The remainder is the function value, which function value is like y, when x equals k. So when we divide polynomials using either long or synthetic division, that final answer, that remainder, is also a form of substitution. If we were to plug an x value in, the 0 for this x minus k, or plug that k into our polynomial, that's the same answer we would get back out. So I'm going to do an example for you where I'm dividing a polynomial. So 3x cubed minus 4x squared minus 41x plus 35. We're going to divide it by x minus 4. I see that as a linear factor, so I'm going to just go ahead and use synthetic division. Drop in my coefficients in order from greatest to least exponents. So that would be 3, negative 4, negative 41, 35. Always remember, if one of those terms is missing in synthetic division, put the 0 placeholder, and that'll make a difference. And then the number that goes outside the synthetic box is always the 0 to this linear factor. So x minus 4 equals 0, x equals 4, positive 4 outside. And then add down and multiply my way to my answer. So drop my leading coefficient 3, multiply to get 12, add down to get 8, multiply to get 32, negative 9, negative 36, and negative 1. Now, just by doing division, I now know two things. Okay. One thing I know is if I take my divisor, x minus 4, and I multiply it by my quotient, which my quotient is going to be made up of these first three terms. This is x squared, x, and a number. If I multiply it by the quotient, 3x squared plus 8x minus 9, and then I add the remainder, which is minus 1. If I were to multiply all that out and combine my terms, I would get the original polynomial, 3x cubed minus 4x squared minus 4x plus 35. That's all the division algorithm is saying. So this is saying d of x times q of x plus r of x would be equal to f of x. Yes, Kate? It's whatever the last is. So this was x cubed, this was x squared, this was x, and this is a number. When you divide by x, the linear factor, they all reduce by 1. So this is now x squared, x, a number, and then this is the remainder. There's always a spot for the remainder. The remainder's value could be 0. And then there is no remainder. The other thing that this tells us is what the remainder theorem said. So remember, the remainder theorem says if you do polynomial division with that factor or that divisor x minus k, then the remainder is f of k. So our k value was 4. What this is also telling me is that f of 4 in function notation is equal to the value of the remainder. The remainder is that function value. So it's like a substitution. If I were to plug 4 in for all those x's and then evaluate it out, I would get -1. And that will always be true. The remainder will always be that function value. What does that mean? 4, -1 is a point on the curve. It's going to lead into our next theorem, which is the factor theorem. And if the remainder is anything but 0, then it's a point somewhere on your curve, but it's not on the x-axis. So then it's not a factor. Is essentially what that's going to say. Does anybody have any questions about those two pieces that it's giving me? Function value and then just that whole piece of like division algorithm. Let's go to that next one that we're leading into the factor theorem. If you'll remember from Algebra 2, this is the theorem that you probably care the most about. How can you tell if x minus k is a factor of f of x? You're going to be on the hunt for factors, for zeros. A polynomial f of x as a factor of x minus k if and only if f of k is equal to 0. Which also means the remainder is 0, right? As f of k is the value of the remainder. That works both ways. That's why the if and only if is there. If f of k is equal to 0, then x minus k is a factor. So it goes forwards and it goes backwards. Here's an example similar to something that might be asked of you on your homework assignment. We are not to that point yet that you may remember from Algebra 2, which is where you kind of have to guess and check for zeros. We're going to do that on Friday. And how can we guess and check to find the zeros? So at this point, we know how to find the zeros of a polynomial by factoring. And they may say, verify that this is in fact a factor. And then use the knowledge that you have to find the other zeros. So we want to verify x plus 3 is a factor of this polynomial. How can we verify a factor? Maggie? Do synthetic division, and what will verify it as a factor? What will happen when you put -3 in? There will be no remainder, or the remainder's value will be equal to 0. Excellent. So I'm going to let you set this up in synthetic, and we all know what should happen, right? It should come out to 0. It does come out to 0. To see if you can set up your synthetic, if you can get to 0 at the end. Very good. Thank you, Nancy. And then if you get to 0, you might think about, how will I find those other zeros? If you didn't get 0 the first time for your remainder, double check that you have put a 0 placeholder for the x squared term. That would make a big difference. Ooh, I got a 0. I always put smiley faces in my zeros. Does anybody else do that? Okay. I do all the time. They make me really excited because that means that's a factor. So yay, yes, it's a factor. Cool. It gets more exciting to have the smiley face when you don't know it's going to happen, right? On Friday when we start guessing checking. You get sad faces. Then you get smiley faces. How will we find the other zeros after we decide that's a factor? Any ideas? Go to the answer, which in the division algorithm we would call the quotient, right? The answer to a division problem is the quotient. Go to the quotient. You divide it by x, so now everything is 1 less. This is x squared minus 3x minus 10. And what are you going to do with your quotient? Factor it. Yeah, this is now quadratic with a factor. We could do quadratic formula. So we're setting our quotient equal to 0 as well, and we could factor x minus 5, x plus 2. 0, so my x's are 5 and negative 2. I think the directions, if I go back up to the top, said verify that x plus 3 is a factor. Yes, we did that. Then find the zeros of the polynomial. I think it would be a good habit to get used to writing off to the side, what are all the zeros of the polynomial? What numbers do you want me to put over there? Negative 3, negative 2, 5. In any order is fine with me. Okay? Negative 3, negative 2, 5. Don't forget about the one that you checked, right? That counts as a 0. Okay, so if it's a factor, then it's also a 0. And so that should be included. Now, knowing what you know from your explorations on Thursday, Friday, each of those appeared only once. They'd have odd multiplicity, so we'd actually cross the axis at those points. I could go to my polynomial function. I have a y-intercept at 0, negative 30, whatever this constant is, because I put 0 into the x's, everything disappears. And I could also do my leading coefficient test. It has a positive leading coefficient, so the right side goes towards positive infinity. It has a negative or an odd exponent, so the left side should be the opposite, towards negative infinity. We are finding, so this list of zeros is for f of x, because remember, Dax said go to the quotient. Okay, so remember in the division algorithm, the quotient times the divisor, which is really x plus 3, is equal to f of x. So this is equal to x cubed minus 19x minus 30. And I couldn't factor this one. But now that I verified that as a factor, I can continue to factor and just set all my factors equal to 0. So you're finding the zeros of the quotient, but they are the zeros of the f of x, because the quotient is a factor of f of x. No, negative 3 is not a factor here. It's not a factor of the quotient, but it's a factor of the polynomial, so it should be included. Yeah. And remember, this one's cubic, so you really should have 3 answers for it. Last thing really quickly, just, think about in the big picture today, what do you know now, besides just how to divide polynomials? What does polynomial division do for you? Here are a few things. Number 1, it tells you the value of the function at x equals k. Now, we can use those values to plot extra points, but what we're really interested in doing going forward is looking for function values that are 0. Because if the y value is 0, that means that we're on the x-axis and we are, in fact, x-intercept. Polynomial division can also tell me that x minus k is a factor of f of x. If the r value is equal to 0, the remainder value is equal to 0. Polynomial division will also tell you when it's not a factor. If you have a remainder, it's not a factor. Right? Like 4 is not a factor of 15 because there's a remainder when you divide. And then also, kind of building off of that piece there, we would have k0 is an x-intercept on our graph if the r value is equal to 0. Because that's the function value, The y value will be 0, then we have an x. The function value is 0, so it's on the x-axis. If there is a remainder value other than 0, it would be some point out on the curve, but it will not be on the x-axis. The y value will be moving up and down. No, there could be real zeros. It's just that that one that you checked was not it. I'm going to pass out this extra review. You now have all the information that's going to be included on the quiz on Thursday. Tomorrow, we're going to go ahead and do complex numbers. Remember, introducing the imaginary unit. But complex numbers are not on the quiz on Thursday. So this is an optional review you can do so that you know what types of things you're responsible for. I'll post the answer key to this online tomorrow. So I won't necessarily check this. This is not required. We won't have a specific class period for review, but this is a good way for you to know what's going to be on your quiz and if you're prepared.